Okay, so I thought I'd record this video about some basic normal curve calculations, things that can be done without a calculator, and these are rule of thumb. These are just estimations, um, and they're usually pretty good estimations, but they're not always exact. If you try to do some of these with a markup math, it might get them marked wrong. Some of them is looking for if they say use these formulas, then you're gonna, or use these rules, you're gonna want to do this. So, anyways, let's go on. So I stole this out of the that OpenStax textbooks. I figured since I recommended you guys download it, I figured I'd use some of the materials from there. So this is an example, and it says, so what are they telling me? So let's see. They're telling me. Let's see. They're telling me that the male heights follow a normal distribution. So because they're telling me it follows a normal distribution, I know kind of do all these normal curve things. So that's one of the first things you want to look for. If it doesn't say it's a normal distribution, you're going to call in a question whether this is appropriate. So they're telling me, there's a couple of things they're telling me is that males, let's see, the mean height of 15 to 18-year-old males in China in those years, that's the mean, and it has a standard deviation of 6.28. Now you see how it says this notation here? All this means is that for any if you use this information to do any calculation, that this distribution is normal. The capital N means normal, so it's a normal distribution. That first number, the 170, is the mean, and then the standard deviation. You won't see me use this notation too much, but I thought it'd be important since we're using this textbook, and in case it came up in some of the test questions I asked you, that you'd see that. So one thing I am going to ask you to do is here's this normal distribution. Make a well-labeled sketch. So here's an idealized normal curve. Notice the means in the middle. And then when I say it's a well-labeled sketch, I want you to mark 1, 2, and 3 standard deviations above the mean, and then 1, 2, and 3 standard deviations below the mean. Now that David Lane applet, if you're watching this before you watch the David Lane calculation applet, just hold it in mind. You want to go check that out. It's a pretty nice applet to use. Your graphing calculators also do the same thing. Spreadsheets do the same thing, except I think the spreadsheet's a little more cumbersome than what the David Lane applet does, and certainly more than the graphing calculator. So when you make a well-labeled sketch, what I'm looking for is that you put the mean in the middle, make some kind of symmetric distribution, put the mean in the middle, draw 3 lines above the mean, draw 3 lines below the mean, and then how you fill these in. You see how it says 1 standard deviation? They got the 176.6 176.28 because they took 170 and then they added the standard deviation of 6.28, and notice if you add that together you get that number. The next number is just you're going to add 6.28 to that answer, and that's where they got the 182. And the next one, of course, you're going to add 6.28 again, and that marks off the top of the 3 standard deviations, which is important. You'll see that in a minute. Then on the bottom side of the mean, you're going to mark the mean minus the standard deviation. That's why it says -1. So they got that 163.72 by taking 170 and subtracting 6.28. Then to get the 157, they subtracted 6.28 again. And lastly, they subtracted 6.28 again. I won't write that down because I'm pretty sure you get the idea. So that's a well-labeled sketch. Now we're going to use it. Okay, so I'm sorry. I guess I heard me cough. I didn't realize it was recording. So what we've got going on here is this is the another normal curve sketch. Notice they have 1 standard deviation above, 2 standard deviations above the mean, 3 standard deviations above the mean, and 3 standard deviations below the mean. Well, it just so happens on any normal curve that if you're within 1 standard deviation of the mean, you're going to catch 68% of the distribution. If you're 2 standard deviations above the mean, that's this area here, you're going to catch 95% of your distribution. And then again, if you're 3 standard deviations away from the mean, that's almost all the interior, that's all that's overlap, right? And you're going to catch 99.7% of the distribution, practically all. Okay, basically 3 standard deviations. If you're more than 3 standard deviations away from the mean, there's very little of the distribution above and below that. Okay, and that's true for any standard any normal curve. Now, what happens is if the standard deviation is bigger, this is all spread out, and if it's smaller, it's all shrunk in tighter. So, but it'll always work for a standard deviation. It'll be darn close. I mean, it'll always work for a normal curve, where it'll be real darn close. Okay. So if I were to ask you, so let's go back. Let me try to get a picture of that other filled-in graph, and I'll show you. So here's that sketch of the heights of Chinese males between 15 and 18, and I've got this filled in. So if I said, what percent of these males fall between 163 and 176, you could tell me, oh, you would notice this is the one standard deviation above and below the mean, so that's 68% falls in that range. If I asked you what percent of Chinese males in this age group falls between 167.4 and 182.56. Notice that this is the +2 standard deviations mark, and this is the -2 standard deviations mark. So that tells me that 95% of the distribution, remember this is the 68, 95, 99.7 rule. So 90, because this is the 2 standard deviations away from the mean, that's the second number, okay? So 95% of the distribution falls in there. So what if I asked you, then of course, what measurements mark off the middle 99.7% of the distribution? Well, you know that's 3 standard deviations away from the mean. So it's those two values, 151 to 88 something? So that would catch 99.7% of the distribution. Okay. So here's a you try it. This came from the text. Why don't you stop this video and try to do this problem on yourself? If you by yourself, if you need a hint, first thing I would do is I would make a well-labeled sketch. Notice this isn't as pretty as what David Lane did, but it works. So remember, draw 3 lines above, 3 lines below, then fill in those numbers. So you can stop the video and try it yourself. I'll do it right now. So I see it the mean. So to use that notation, I know this is normal with a mean of 52 and a standard deviation 11. So I can just start filling this in. This is 52. Then I'm going to add 11 to that, which is 63. I'm going to add 11 to that, which is 74. Then I'll add 11 to that, which is what, 85. And then I'm going to subtract 11 coming down. So what's that, 41, and then I'll subtract 11 again, which is 30, and then I'll subtract 11 again, which I think is 19. Okay? So once we get our nice labeled sketch, all we got to do is, all we got to do is answer the questions. So 68% lie between what two values? Well, I know that 68%, remember we've got the 68, well, the nice 68. 68, 95, 99.7 rule is what we're going to use, and this is plus or minus 1 standard deviation. This is plus or minus 2 standard deviations. This is plus or minus 3 standard deviations. And so what percent? 68% is the 1 plus or minus 1, which is this region right here. So to answer this question, we'd say these values are 41 to 63. And the z-scores are plus or minus 1, or so minus 1, positive 1, right? Because remember, all a z-score is how many standard deviations away. They've changed this app. I used to be able to have a better pencil. I'm not quite sure how to use it. More of a drawing app. Sorry about that. Just total aside. Then they asked me, how about 95? Well, 95% is 2 standard deviations away. So that will be the 74 and the 30. So 30 to 74, and those are plus or minus 2 standard deviations. And then, of course, for 99.7% falls between what two values? Well, it'll be 85 and 19, and that's plus or minus 3 standard deviations. Okay, so pretty straightforward, and once you make the sketch, it's really easy. Now, sometimes we want you to use other values than, or you're going to use the plus or minus 1, plus or minus 2, plus or minus 3 standard deviations, but it's going to be a weird mix. So I'm going to give you this, we're going to create this little sketch here, and maybe this will help you. Let's see, I think that's all good. Let's try this. So here's a little normal curve sketch. There's better drawn pictures out on the web, but let's go plus or minus 1 standard deviation either side of the mean. If there's 68% of the data that falls in that range, if we split that in half, because these are symmetric, that gives me 34% in each of these little pieces. So between 1 standard deviation below and the mean, there's 34%. Between 1 standard deviation and one above, 34%, okay? So there's that. And then also, if we think about that, if there's 68% in this range, isn't outside that range 32%, 100 minus 68? So that tells me there's 16% in the upper. Now this doesn't stop at 3 standard deviation. This goes on forever. Okay, I mean essentially it does stop at 3 standard deviations, but there's always a little bit more. So if I asked you what percent fell less than 1 standard deviation, you'd tell me 16%. What percent falls more than 1 standard deviation? 16%. Okay? And then what about, let's shrink this, let's see, can I shrink this up right now? Let's see if they'll let me, oh yeah. So now what if I'm 2 standard deviations away from the mean? -2, +2, 95%. Well, what percent's outside that? Well, I think it's 5%, and since this is symmetric, half will be above. So 2.5% and 2.5%. Okay. So if I asked you what number marks off the bottom 2.5%, you'd take a look at whatever number you wrote 2 standard deviations away. If I asked you what number marks off the upper 2.5%, or 97.5% it falls less than, we'd say 2 standard deviations. Okay. So I just want to show you one more thing with this empirical rule, the 689599.7 rule. Then we'll go look at the David Lane calculator, and that'll give us good exact values, and it's honestly a little easier this. But, I mean, like I said, this is a good rule of thumb. Sometimes it's nice to know what percent falls in between the lines. I know that 34%, we already talked about that, 34% on each side of that, and if we know that 95% of the distribution falls within 2 standard deviations, half of 95 is 47.5. If this part is 34%, this part will be 47.5 minus the 34. So I think that's 13.5. So there's 13.5% here, and the same deal there. There's 13.5% between. So this is what's happening, falling between one standard deviation above and two standard deviations above, or z-score 1 and 2, about 13.5%. Okay. Then, I'm sorry here. Let me write. Let's see here. Stop the video for a minute. Finishing writing this all out and showing you how to do it all, I thought I'd find this picture online. Notice that it has the 34 here as a pointer. Notice that it has 34 from our calculated values, and there's the 34% and 13.5% in each of those places between 1 and 2 standard deviations above the mean. And to get this part out here, if there's 95% of the distribution falling here to here, that means there's 2.5% above it, 2.5% below it. I think I've already said this. And so all we got to know is really little pieces of this, then we can find out the rest of it. And again, these are just rules of thumb. We'll use other ways to do this.